What do we do if we have a bunch of data that we need to store and we don't know how much we need to store either at compile time or at runtime, right? This could be something that's going to ebb and flow throughout the course of our application, right? Something like game objects, right? When we're playing a game, there's a lot of dynamic things being created, right? Enemies are coming and going. We're shooting bullets or other projectiles. There's various debris or obstacles that are being created on the fly. There are NPC characters that are created and then they go away as we leave a zone, etc. So we need something that's flexible, and a vector or a DynArray might be the case. These classes, as with almost every data structure, are going to be template classes. That is going to give us the maximum versatility, right? We'll be able to create instances of these objects that can store any different type, and we'll be able to use the same code for that. And that's going to increase our code reusability, which is something that we want in object-oriented programming. So for the rest of this lecture, we're going to look at the DynArray and look at the different functions that we're going to implement. This is going to give us similar behavior to the STL vector that we've already worked with, but it's going to be a somewhat simplified version of that. We don't have the time to delve into making a one-to-one analog to the vector, so we're going to look at some of just the key functionality, and we can kind of understand the pros and cons of using a vector, because a vector is not going to be the best data structure for every situation. What do we do if we have a bunch of data that we need to store and we don't know how much we need to store either at compile time or at runtime, right? This could be something that's going to ebb and flow throughout the course of our application, right? Something like game objects, right? When we're playing a game, there's a lot of dynamic things being created, right? Enemies are coming and going. We're shooting bullets or other projectiles. There's various debris or obstacles that are being created on the fly. There are NPC characters that are created and then they go away as we leave a zone, etc. So we need something that's flexible, and a vector or a DynArray might be the case. These classes, as with almost every data structure, are going to be template classes. That is going to give us the maximum versatility, right? We'll be able to create instances of these objects that can store any different type, and we'll be able to use the same code for that. And that's going to increase our code reusability, which is something that we want in object-oriented programming. So for the rest of this lecture, we're going to look at the DynArray and look at the different functions that we're going to implement. This is going to give us similar behavior to the STL vector that we've already worked with, but it's going to be a somewhat simplified version of that. We don't have the time to delve into making a one-to-one analog to the vector, so we're going to look at some of just the key functionality, and we can kind of understand the pros and cons of using a vector, because a vector is not going to be the best data structure for every situation. This class is going to have just a couple of data members. The key ones that we're going to have, or actually the only ones we're going to have, are a pointer that is going to point to a dynamic array. It's going to be of type, which is going to be our templated name, right? We've dealt with templated classes in systems programming, and we'll look at those again in some of the code that we'll be writing within some of the lectures. But this is going to be our dynamic array that we'll be using throughout the class methods. Now, we know that in using an array, once it leaves the scope that it's been created in, it then becomes just a pointer. So we need to keep track of the actual size of that array throughout the rest of the methods, right? This is why when we pass an array to a function, we always pass the number of elements in that array as well, with the exception to that being a string, because a string or char pointer has a null terminator at the end. So this last data member here, the capacity, that is going to be the number of elements that are in the array. So that's going to be the size of that array, right? We're also going to have a size data member because the array may not be full at all times, and we'll see how that works a little bit later on. We've already seen that behavior with the vector class as well. This is an overview of the functionality that we're going to implement inside of our DynArray lab. As we can see, it's pretty pared down from what we might see in the vector class. If you go to the MSDN for vector, you'll see that there's quite a bit more functionality, but we're looking at just some of the key functions or key methods that will kind of give us an understanding of what makes a vector tick underneath the hood and what makes it a good choice for storage of data in some scenarios, but not so much in others. The first thing that we have is our default constructor. This is going to take in an optional starting capacity, and we'll look more into the detail of that once we get to that slide. We are going to be dealing with dynamic memory in this class, so we will have our destructor to clean things up. We're going to also, because we have dynamic memory, we'll be implementing a copy constructor and assignment operator. These three functions here make up the rule of 3. We're going to overload the bracket operator so that we can access an element individually for either reading or writing. This may be the first time that we've overloaded an operator outside of the assignment operator, so we will look into that when we get to some code. We will have accessors for the size and capacity. These will be just a very simple get type of functions. We're going to have a clear function that can be a helper. So that's something that we may use in our destructor or just in general if we want to reuse an object. We will have an append function. This is going to be kind of the equivalent of push back in the vector. And then we will have our reserve functionality where we can reserve more memory if we have reached our capacity. And again, we'll talk more about that when we get to that particular slide. Our constructor, much like the constructor of any other class, is designed to initialize the data members of the class. Now, in order to make this constructor a little bit more flexible, we're going to have the option to pass in a data member to let us know what we want to start that array at. So our constructor will look something like this. So we're going to have a DynArray, and we're going to take in an integer, an unsigned integer, because we can't have an array of negative sizes, right? Which is going to have a starting cap of 0 as its default. So if I call this function and create an object and I pass in a particular value, so let's create a DynArray that stores ints, right? Because this is a template class, and we'll say that this is we'll just say DA and 10, then that starting capacity is going to be 10, and we'll need to dynamically allocate our array to be of that particular size. Whereas if we created that array and we did not pass a value in, then that would be use the default starting cap of 0, and therefore we would want to start our array out at null or 0, right? So the reason why we're giving the option to pass in this starting capacity is because that can speed up our application. As we'll see in some of the coming slides, when that array becomes full, we will need to resize it, and there's going to be a cost in doing that. So if we have an idea in our application of approximately how many things I am going to have, or some good starting value, then that will mean that we will not need to resize as much, and we can cut down on some of that overhead. Since we have dynamic memory in this class, we will obviously need a destructor. The built-in one is not going to be good enough. So in this, all we'll need to do is clean up all of our dynamic memory. Now, we're going to have another method that we'll talk about here a little bit later called clear that's also going to clean up our memory. So if we want to be efficient, we can reuse that method here. Since this class has dynamic memory, we're going to have to implement the rule of 3, which we've already seen the destructor. The next one up would be the copy constructor. And so what that needs to do is, of course, do a deep copy of all of the dynamic data members and a shallow copy of any of the non-dynamic data members. So anything that's a pointer needs to be deep copied. Anything that's not a pointer can just be shallow copied. As we saw in the debugging lab, there is a shortcut to calling the assignment operator, which helps on code duplication, right? It means that we won't have to essentially write the same block of code twice. We can just have the copy constructor call the assignment operator. The assignment operator has a very similar results to the copy constructor. It's just a different context of when they are called. So because an assignment operator is called on an existing object, the first thing that we always need to do is a self-assignment check. If we try to copy over an object and we're dealing with dynamic memory, then that is definitely going to cause a problem, because we're going to end up deleting memory that we're trying to copy from. So after we've done our self-assignment check, we need to clean up existing memory, because we're dealing with an existing object that has already had new called on it at least once within the object. So we need to clean up that memory before we go in and do our copies of our data. Again, deep copying anything that's dynamic and shallow copying the other data members. And then at the end, right, we would return the invoking object by reference, which would allow us to daisy chain assignments just like any other type of assignment. We're going to write 2 versions of this bracket indexing operator so that we can treat our DynArray objects just like we would with a standard array. This is very similar to the behavior that we have within the vector class, and we can do that because we're dealing with an array behind the scenes. So if we have an object called DA, right, for DynArray, then we could assign a value to it, right? Let's say that we're dealing with integers, right? Or we could print out a value with a different version of that operator. So we're writing two versions to show that you can have a read-only version or a write-only version of this operator. So if for some reason you wanted to provide only a read-only version of this operator for your class, and you didn't want someone to be able to manipulate the data inside of your class using the bracket operator, then we could only overload the one version. So it gives us some options there. But we're kind of opening things up just like we have with the vector class. So we're going to overload both versions. Here we have just a couple of quick accessors that will allow us to check either the size of the DynArray, the number of elements that are currently being stored, or the capacity, the number of items that can be stored before we have to resize. We're not going to write any mutators or modifiers where we would be able to change this data. So this is just some get methods so that we can access this information from outside of the class. The clear method can be used to essentially reset an object so that it can be reused. A lot of times in a larger application, we may be running the same thing multiple times, right? So we may need to reload a level in a game, or supply a new search query to a search engine, which would then need to load a bunch of different results. So we don't want to or need to create a new object to store all of that new information, but we want to reuse that existing object, and therefore we need to clear it out first, and clear would be a good method to do that with. So that's going to essentially clean up and delete all of the dynamic memory that we may be using within the current object, and also set our other non-dynamic data members, the size and the capacity, back to their default values. Reserve is going to be the big function for this lab. Now, what this is designed to do is handle the resizing of the array. And we'll take a look at an example of this over on the whiteboard in just a few moments. So there are a couple of different paths that this function can take. It is going to pass in, optionally, a value. If they pass in a 0 for that value, meaning they don't pass in anything at all because that's the default, then we're going to do one of two things. If the current capacity of our DynArray is 0, then we're going to set the capacity to 1. Otherwise, if the capacity is something other than 0, then we're going to double the current capacity. So we're going to make our capacity twice what it currently is. If a value is passed in, then we want to resize the array to whatever that new capacity is, as long as that new capacity is larger than our current capacity. After we've determined our new capacity, there's a little bit more work that needs to be done in this method. The first thing that we're going to want to do is create a new larger array to copy over all of our existing information, and we'll see this in the diagram coming up. After we have copied over all of that data, then we can go ahead and clean up that memory. So the old, smaller array can then be deleted, and then we can reassign our pointer so that it is pointing to our new valid memory, and thus our object can continue to work and grow. And finally, the last method that we're going to talk about here is append. This is going to be similar to push back, where we're going to add in a value, a piece of data, whatever we're storing, into the next available index in the array. If the array is already full before adding, then it will need to be resized first, and we can do that by calling reserve. So after we do this check, we can then either add it in because we have room available, or we resize first and then add it in. And we'll take a look at that in the diagramming as well.